and welcome once again back to the channel. This is again a bit of think and do. This particular topic area is shape and space. So all these questions today that I'm going to do are from the shape and space area. So without further ado, I'm going to crack on and get on with these. Again, all these questions are GCSE questions of past exam papers. You will find them online, I'm sure, various different sources you can go to. My particular favourite source is Maths Genie, so my thanks to them and I'll mention their name a lot because they're a good website to go to for exam papers if you want them. So this particular question here is a tessellating pattern with 4 different rectangles, and you can see that they have they're talking about identical rectangular tiles, and they're asking you to find the total area. So this is a problem in itself that you've got to sort of construct an idea about what to do. Of course, the key thing about rectangles is how do you work out the area of a rectangle? You do length times width. So length is important, width is important. So for that reason, I'm going to call the length L and the width W. And for each rectangle, because they're all the same, that's going to be the same readout for each one. So we're going to fill those all in just to make sure that I know what's going on. Now you can see here across the top we've got 11 centimetres, but if you look carefully we'll have 2 lots of lengths, so one length here, one length there, and then another width. So 2 lengths plus a width making 11 centimetres. And then across the side here we have a width and a length making 7 centimetres. So again I'm going to write that down, length and width making 7. Now what is this? It's 2 equations, 2 unknowns. So it's a simultaneous equation system, a very simple simultaneous equation system. If we do this particular calculation, take away this one, you can see we can eliminate the width. The width will disappear. 11 take 7 is 4. And then 2 lots of length, take away 1 lots of length is another length. So it's just 1 length. So the length is 4 here. If the length is 4 and they add to 7, then the width must be 3. And so the area of each particular rectangle is going to be 12. 4 times 3. And so you've got 1, 2, 3, 4 rectangles. 4 12s being 48. So just putting that in here, 4 marks for that. Very straightforward once you realise what you've got to do, but again quite a complex start to the question in that you have to figure out what you need to do for each particular rectangle. The second question, again shape and space, you will see is again not very common. But an interesting question because it makes up a lot of areas here. There's a lot of areas being tested in this particular question. This one has some complexity to it. You can see there's a range of different shapes going on here. You've got sort of 1, 2, 3, 4. So you've got a sort of five-sided shape here and a 5-sided shape there. You're being asked about covering the floor with tiles, so it's an area question. Tiles are sold in packs. 1 pack of tiles covers 2 meters squared. Pack of tiles normally costing £24.80. Mary gets a discount, 25% off. Mary has £100. Does she have enough money? So let's do one thing at a time. Try and break it down into different sections. So the first thing I'll do is try and break up the shape and work out the area of that shape. So I'm going to break it up here into what will be effectively 2 trapezia. So a trapezium here and a trapezium there, and then a rectangular shape in the middle here. So you can see this width here is 1 and this length here is 3.4. So this area in here will be 3.4 meters squared because 3.4 times 1. Over here on the right hand side I've got the trapezia here, and again the area trapezium is the half the sum of the parallel sides times by the distance between them. So this is 2.2, this is 3.4. So half the sum of those, half the sum of that, and then times the distance between them times this distance here, which will be, but if that's 1 and this is 3, then this is going to be 2 remaining. So this is going to be 1, that's going to be 1. So again, that's going to be fairly simple to work out. 3.4 plus 2.2 is 5.6. So you've got this calculation. And so just make the decimal point a bit bigger. So 2.8 for each of those. And again, each one of those is going to be the same. So I'm going to fill that in over here. Haven't really needed to use a calculator yet, but probably will in a minute. So the total area, first of all, let's show the examiner what we're doing. It will be 2.8 plus 2.8 plus 3.4. So this is going to be 5.6 again, and then 8 is going to be 9 meters squared overall. So that's 9 meters squared. You can see that's going to add to 9 meters squared. Now, we're then told the packs of tiles cover 2 meters squared, so you're going to need 5 packs because you can't cover, you won't be able to buy half a pack at the superstore or whatever, so you need 5 packs. So 5 packs needed. So I'm just showing the examiner that I've worked that out. The pack of tiles, £24.80, she's getting 25% off. So we need to do 0.75 of £24.80 to work out what 3/4 of £24.80 is. Again, you might want to reach for a calculator. I don't necessarily feel that you need to here. You could probably work this out, but I'll just reach for the calculator. It seems easier to me, but £18.60 is what you'll get. Many people ask me what I do to work out how this would work, but I could do 1/4 of this quite easily because 1/4 of 24 is 6 and 1/4 of 80 is 20 pence. So £6.20 is what you're taking away, and you can see those are £6.20 apart. So if you didn't have a calculator, you can quite easily do it. But there's £18.60. She needs 5 packs, so I've got to do 5 lots of £18.60. And again, I'll just plug that into the calculator. It's 93. And so, does she have enough money? Yes, because she's got £100, so there'll be £7 change left there. So, nice lot of working here for the 5 marks that you need. Quite straightforward, just a little bit of testing on area of trapezium and so on. Next question really could have been within 3D trig, but is nevertheless an interesting question all the same. This particular question, the square base pyramid, is talking about the surface area of a pyramid. So surface area of a pyramid will be the area of this side, this side, this side, the back side, the bottom, all added up together. So it's telling you the angle between any sloping edge and the plane ABCD is 55 degrees. It's telling you that any sloping edge and the plane is 55 degrees. So if I was to draw a little diagram of how this looked, straight down to the base here, take a sloping edge, this here would be 55. So as a right angle triangle here, you can probably see that modelled, would be 55 degrees. So the first thing to do with any 3D trig problem is to work out the diagonal on the base. That's the key thing. So I'm going to start by looking at that. So if I sketch the base, so A, B, C, D, I'm going to work out what this distance is from the middle to the side here, the diagonal. So I've got 20 here and 20 here because it's a square base pyramid. You can see we're constructing a right angle triangle. If I was to work out the whole diagonal, it would be 20 squared plus 20 squared square rooted, so 400 plus 400, square root of 800. So the distance from middle to the end will be root 800 divided by 2. So that's going to be root 800 divided by 2 from there to there. So really small, but that's what it will be. So then what do we do? So we've got to work out the height now, I think, would probably be the sensible thing. So I'm going to work out this height Vm, because the key thing is we've got to have a strategy for working out the area of each triangle. So if I work out, the strategy should be here, if I work out the height Vm, I can then construct another right angle triangle here, which I'll draw very carefully, which will be with the height here and the sloping edge and this side here, and then I can use my calculations to work out what this is. And once I know what this is, I can do half the base times the height to work out the area of this triangle. And so all the 4 triangles will be the same, 1, 2, 3, 4. So we're going to just use this triangle VMN, we'll call it, and I'm going to sort of construct how that's going to work eventually. But I need VM first, so I'm going to look at VMB. So VMB. So I'm going to draw that first. So, quite an interesting question. This needs a lot of thinking, a lot of calculation, but we are getting there slowly. So this is the root 100 over 2 that I had earlier. This is the 55. We need the VMs. This is the opposite. This is the adjacent. This is the 55. So we know tan 55 will be VM over the root 800 divided by 2. So we're going to calculate those together. You need a calculator for that, obviously. So I'm going to put that in. The good thing about these calculators again is you can put it in just as it says, so 1055, and I'm going to multiply it by root 800 over 2. Be really careful about this. I'm going to use some brackets here just to show that it's going to be root 100 divided by 2. Let's try that. Oh, made a mistake. Hang on a minute. Let's try that again. So I'll do it the other way around this time. So I'll do 800 divided by 2. So that's 10 root 2. And then times by tan 55. Let's try that. Yeah, 20.19. So VM is 20.197068. Okay, cool. So that's the height here, 20 point something. We're going to then use the calculation for VMN. So I'll show you that triangle again, VMN. We're going to work out this length now. So I'm going to draw another triangle. VMN. The distance from M to N is going to be 10 because it's half as much as this. We know what this is because we just worked it out. It's 20.197068, and I need this one. So again, this is going to be that squared plus that squared square rooted. So again, I'm keeping the number in the calculator. I haven't touched the calculator. So that squared plus 10 squared, and then I'm going to square root that. So 22.537. 11041. So it's I need to show the examiner what I've done. So I'm just showing that just to show what I've done. So I'm just doing that to show them what I did. 22.53. So that's now the height. So the area of each triangle will be half the base times the height. So half of 20 times this height, 22.5371141. Try and keep that nice and open because you don't want to make a mistake with the rounding. So you'll get 225 for each one. 3711041. There's 4 of those, so we need to multiply that by 4. So that's going to be 901.4844166. Then we add the base, which is going to be 20 times 20, 400. And so we're going to add those up. And I'm going to get 1301.484417. But then back to the question, it asked me to give the answer to 2 significant figures. So to 2 significant figures, this is going to be 1300. And that hopefully is the answer. Again, just a straightforward 3D trig question really, but you do need to be careful about how you're setting it all out and what you're doing, making sure that you're showing the examiner exactly the kind of steps that you're going through for each one, because that's quite critical for this. This next question is a sphere question, hemisphere question. So it's talking about the volume of a hemisphere. It's asking you to give your answers in multiples of pi, so I'm going to ignore the calculator for this. The calculator would have been not allowed. So we're asking for each strategy, we're going to get the total surface area. So we've given the 2 formulas over here, that's handy. So the first thing to do is to think about what we need. The critical thing for both the volume and the sphere surface area is the radius. We need the radius for each one. So we need to calculate the radius for each one. We're being told the volume, so volume is 250 over 3 pi. We know that the volume of a sphere is 4/3 pi r cubed, so for a hemisphere, it's going to be 2/3 pi r cubed. Pi's on both sides cancel each other out. We're going to have, if I do multiply both sides by 3, I'm going to get 250 equals 2 r cubed. And then divide by 2, so 125 equals r cubed, and then I know that that must mean that the radius is 5 centimetres. Now that I know the radius, I can get a surface area. The surface area will be this bit plus the bit on top. Well, this bit here will be half as much as this because this is for a whole sphere, so 2 pi r squared. But then you've got the bit on the top as well, so that's 3 pi r squared. So we know what 3 pi r squared for the surface area. So again, I'm going to just tell the examiner what I'm doing here. So 3 pi r squared, 3 times pi times 25, so that's 75 pi centimetres squared. And that will be the answer that will get you the 4 marks. This next question is a rectangular question, talking about shaded areas and how you work them out. Again, all these questions have a lot in common. They're all like area questions or related to area questions. So there's quite a lot in these questions that's very similar. So just get used to the idea that you're going to be doing something with area at some stage in the 3 papers that you'll get. Now, the strategy for this one is to work out the shaded region. So we've got to work out the area of the big rectangle. So the area of the big rectangle, first of all, as an expression. Will be length times width, so x plus 6 multiplied by 3x minus 5. So as an expression, I'm going to work out the first 2 terms multiplied, the outside terms multiplied, the inside terms multiplied, and the last 2 terms multiplied. So minus 5x is 13x, and then minus 30. Okay, so that's hopefully an expression that we'll get for there. The triangle will be half the base times the perpendicular height, so it's x times 3x minus 5. Careful with my brackets here, so it's 3x squared minus 5x. And so the difference between these two things hopefully should make this. So we'll show that being calculated now. So I'm going to be careful with brackets here just to show that I'm taking the whole thing away. So 3x squared, take away 3x squared, that's going to cancel. 13x minus 5x is 18x, 2 minuses make a plus, and then you've got the minus 30 here, and that's what they wanted you to show. So you've got that down, and hopefully you'll get your 4 marks. The next question, which questions come across? Again, these are quite quick now. To these ones are quite simple, quick. Primitive of a square being 120. So we've got x here, x here. We're told that 4x equals the square root of 120. It's asking you to work out the area of the square, in other words, x squared. So first of all, x is going to be root 120 divided by 4. Well, root 120 is a third, so that's 2 root 30. And so x is going to be half root 30. So x squared would be the multiple of these two things. So if we square the half, that's a quarter, and then square the root 30, that's just 30. So we're going to have 30 over 4. And so that's going to be 15 over 2, 7.5 centimetres squared. Really quick to do it, but you've got to be good at surds and know your surds. This question is quite an interesting question, question 7. It's definitely come up a while ago, but has thrown candidates for sure. So you just need to be very cautious about how you approach this particular question. It's talking about a triangle DEF. So this is DEF in here. Inside a rectangle ABCD, show the area of the triangle DEF is 8, and you must show all your working. Now the key to this question is to make very little assumption as you can, but the key thing is have a strategy, and the strategy will be work out the area of the big rectangle, work out the area of that triangle, that triangle, that triangle, take it away, and what you're left with is in here. Okay, that's the key strategy. If you try and do it another way, there's a lot that can go wrong, so it's important to model it that way. I've seen some candidates approaching this with working at this first by using this right angle triangle, 2 squared plus 2 squared square rooted of that, and then halving that to times the perpendicular length. But that's assuming that the height is halfway through the base, and so that's where that goes wrong. So be careful about that. That's definitely not the way to do it. So let's work out the area of the big rectangle first of all. What do we need? Well, we need this side length, and you can see there is a little bit of a right angle triangle system here that we need to get this side length. This squared, take away this squared, square rooted will be this one. So I'm going to write that expression down real quick, just to show the examiner what I'm doing. So 2 root 10, so that's 4 times 10, so that's 40. Take away 4, so that's 36 CD squared, and so 6 will be CD. Okay, so square the 2, square the root 10. Okay, that's how you get the 40. So this is going to be 6. Now, if this is 6 and that's 2, this has to be 4, and this here is 4, so that's going to be 4 as well. The area of the big rectangle, therefore, just going to try and get that into shot so you can see it. Area of the rectangle will be 6 fours, 24. Just show the examiner that I did that. And then the area of the little triangles, so I'll label them up. So 1, 2, 3. So area of triangle 1 will be half the base times the height. So 3 twos are 6. Area 2, half the base times the height. So 2 fours are 8. And then root 3, area of triangle 3, half of 2 times 1 is 2. Now, 6 plus 8 plus 2 will be 16, and so you need to take 16 away from 24 to get the DEF. So 24 take away, it's going to show that I've added that all up. 24 take away 16, and that is indeed 8. So you do get to show it quite quickly, but it does need some thinking and some thought. Okay, next question. This is a interesting one. Okay, yeah. So here we go again. This one is a sphere question. You can see these are quite common. So there are some things that you need to know about this. What's interesting about this is it doesn't give you the surface area formula the one earlier did. So you probably will need to learn the surface area of a sphere and the volume of a sphere as well. So the volume of a sphere is of course 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. So just be aware of that and make sure you've got those remembered. Now this particular question has got a sphere of radius 6, solid cylinder next to it here. Total surface area of the cylinder is twice the total surface area of the sphere. So we're going to use that fact. We're going to stop there and just use this first of all to work out what my height is. Okay, so that's the strategy to start with. So we're going to look at the surface area of the sphere. So surface area of sphere, as mentioned earlier, will be 4 pi r squared. So we're going to have 4 times pi times 6 squared, so that's 36. 36 times 4 will be 144, so it's 144 pi. That's going to be the surface area of the sphere. The surface area of a cylinder is a little bit more complex. When you roll this out, you're going to get a rectangle, and the rectangle will have the length of the rectangle will be the diameter of this particular circle on the base, and then of course you've got the 2 circles top and bottom to add up as well. So it's quite an interesting complexity to that. So we're going to do the diameter of the base first. So because the radius is 3, we're going to do 2 pi r, which is the circumference. So that's going to be 6 pi, and then you're going to have that times the height to get the rectangular length, so that's the rectangular bit, and then the 2 circles, the bottom and top circles, so pi r squared for each one, so that's 9 pi, so 9 pi plus 9 pi here. Okay, hope you can see that. So that's going to be 18 pi, and this is going to be 6h pi, so it's 18 pi and then plus 6h pi. Okay, it's a little bit complex, but that's how it goes for now. Then you've got to understand that the cylinder is twice the total surface area of the sphere. So we're going to use this fact. So I'm going to take out pi as common, just to make it a little bit easier for myself. We're being told this is twice the surface area of the sphere. So twice that 144. So 288 pi is the expression we're going to get. You can see we're going to cancel the pi's out straight away. Leaves us with 6h being 288, take away the 18 is going to be 270. and then 270 divided by 6 is 45. Okay, so I know the height's going to be 45 centimeters. That's just half the question for now. You can see it's quite complex. Then it says work out the ratio of the volume of the sphere to the volume of the cylinder. Okay, this is slightly easier. So the volume of the sphere, first of all, just going to give you space for you. So the volume of the sphere, 4/3 pi r cubed, reminder from earlier. And we worked out the radius, or we knew the radius was 6, so 6 cubed. So 6 cubed is 216, so 216 times 4, and then divide that by 3. Okay, I'm assuming that this particular question didn't involve a calculator, so you've got to be quite canny about how you work these things out. So 216 times 4, I'll work that out first, so it's 24, 4, 5, 6, 4 2's 8. I think that's right, 864, so 864 divided by 3. 3 into 8 goes twice, 2 remainder, 3 into 26 goes 8 times 2 remainder, 3 into 24 goes 8, so it's 288 pi. Okay, I've tried not to use a calculator because I'm not sure this is a calculator question or not, but I haven't touched a calculator yet, so hopefully we're okay. Volume of the cylinder will be area of the base times the height, so it's pi r squared h. We were told in the question that the radius was 3, so pi times 9 times the h that we got earlier, so that's 45. And again, 9 times 45, we need to work out what that is. So I'll just do that real quick here. So 9 5 is 45. 9 4s are 36, plus that 4 is 40. So 405, I believe, pi. And it's asking for a ratio. So we're going to put the ratio of the surface area of the spheres first, so 288 pi to 405 pi. The pi's cancel, so you're just left with 288 and 405. And then you're looking for numbers that go into 288 and 405. Well, I can see that 9 does, because 16, 18, and this is going to add to 9 as well. So 9 goes into both things. So if you divide both sides by 9, you'll get 32 and 45. So that's the ratio that you needed. You probably could have left it as 288, 405, although it's not in its simplest form. You probably would have got 4 in a mark. So you still get a good gathering of marks, even if you don't quite get all the way with it. Second to last question, still motoring on. This one here, again, another sphere question. You can see these are quite common, so get those spheres formulas learned. Solid shape is made from a cylinder and a hemisphere. The radius of the cylinder is equal to the radius of the hemisphere. The cylinder has a height of 10, and the curved surface area of the hemisphere is 32 pi. And it says work out the total surface area of the solid shape. Because it's a hemisphere, we've got the surface area, this curved surface area here, this bit they're talking about, will be 2 pi r squared. Okay, because we know the curved surface area, we know the surface area of a sphere in general is 4 pi r squared. So the curved surface area of the hemisphere would be 2 pi r squared. So that's helpful for us to start with. We need to think about that. So we're told in the question that 2 pi r squared is 32 pi. The 2 pi's will cancel, leaving with the idea that r squared is 16, so r is 4 centimeters. Okay, you can work that out really quickly. That means then that the surface area of the cylinder, so that's this bit here, we can calculate that. Again, similar to the previous question, it's the diameter of the base times the 10. So the diameter of the base we know now because the radius is 4, so the diameter is going to be 8, twice as much. So it's 8 pi, the circumference, times by the 10. So it's 8 pi times 10, that's this that's the rectangular bit when you rolled it out. And then you've got to add on the base here, and then this surface area from the top. So you've got to add on that. So the base will be pi r squared, so because this is 4, 16 pi. And then the bit from we had from earlier, 32 pi, the curved surface area at the top. So again, 32 pi I've added in. So that's going to be 80 pi plus 32 plus 16, which is going to be 48 pi. And that adds up to 128 pi. So that will be the answer. Again, I haven't touched the calculator. It's all been done without touching a calculator. So helpful to know just these different relationships that you need for the sphere. These two questions are quite tricky, so I'll take my time on a little bit. Realise the video has already gone on for half an hour, so apologies for the length of the video, but hopefully this is helping you a lot. And of course you can take a look at these questions again in your own leisure at some point later on. This particular question is a trigonometry question, so it could have overlapped into another of the areas that I've done on the think and do questions, but I put it in here because it was about area. So it's two non-right angled triangles. You're being asked to calculate the area of a parallelogram. Now the quickest way to get the area of a parallelogram is to get the length of the base times the perpendicular height. So we need to work out the perpendicular height. That's the key thing. So if I draw a little sketch here of what that perpendicular height would look like, we're trying to work out this. So that's quite important to start with. It would be therefore quite important for me to figure out what this angle in the corner here would be. So the strategy is work out the angle in this corner, use that and trigonometry to work out the height, and then I can work out the area of the parallelogram. So that's the strategy to start with. Given that we're looking at mystery angles and mystery sides and so on, and non-right angled triangles, we're talking about sine rule, cosine rule. Which one do I need here? It's going to be sine rule that you'll need. So I'm going to have the mystery angle version of the sine rule. So sine 100 divided by 11, so that's this relationship over this, is sine of whatever d is over 9. So it's this sine of that divided by that is sine of this divided by this. So it's a sine rule. We can do some manipulation to work this out. I'm going to need a calculator for this really quickly. You can tell I'm going to because it talks about significant figures later on, so no worries about using a calculator here. I'm just going to try and make that look like a multiply because it is a multiply. So here we go. So 9 sine 100. Do that bit first, and then I'm going to divide it by 11 now. So 0.85, that's the sine d, and then I've got to inverse sine that. So inverse sine the answer to get my angle, so 53. So 53.68292309 ... Okay, that's the angle in this corner here, the 53.7 roughly. So we've got that calculation. We now need to figure out how to work out the perpendicular height here. And again, that's not massively straightforward. So we're going to need to think about how we do that. So first of all, we are going to need to figure out what this angle is, because if we can work out what this angle is, that would help us because we've got a side length here, we've got 9, and we've got this angle, and so we can use this angle, this side length and this angle to work out what that length is here. Okay, don't assume that this dotted line goes halfway through the angle. That's a key error. People always assume it's 50 either side. It definitely does not bisect that angle, so you can't assume that. So how do we work this out? It's very straightforward, isn't it? Because we've got 100 here, we've got 53 point something there. These three add up to 180. So we're going to use the fact that they all add up to 180 to work out this angle in the corner at C. So, so I'm going to show the examiner I'm doing that. 292309, and that's going to be the angle in the corner at C. So let's just work that out. So 180, take away that, take away 100, and that is 26.31707691. Okay, that's the angle in the corner at C. Now I'm going to calculate, because I've got a right angle triangle here, 26 roughly, and I need this height. This is the opposite, this is the hypotenuse, so it's a sine relationship. Okay, so again, I've just written it all out so the examiner knows what it is. So AM will be 9 multiplied by this. So I'm just going to work that out real quick. Lots of work to do for this question. So 3.99 roughly. Okay, and then that gives you the height now, 3.99. So you multiply it by the base to get the area. So the area will be 3.99 45307 multiplied by 11, and then give it to three significant figures. So we're going to do that real quick. So 43.89, so it's the three significant figures, it's 43.9, and that is enough, hopefully, to get all of the marks that you need. Question 11 down here, again, this is the very last question. Similar to a question from earlier, the length of the rectangle being the same as the length of each side of the square. So you've got a rectangle and a square. So you've got rectangle here, that's L, this is going to be W, okay, and then you've got the side of the square here, and again the length is the same, so all of these are the same. Now they do tell you the length of the rectangle is 4 centimeters more than 3 times the width, so we've got an expression for this. So it's 3 times the width plus 4, so 3W plus 4, and we're told the side of the square is the same, so I'm going to use 3W plus 4, 3W plus 4, 3W plus 4, and so on, because we know it's a square. And we're told the area of the square is 66 centimeters more, so the area of the square would be this times this. So 3W plus 4 times 3W plus 4. Again, straightforward pairs of brackets to multiply, so 9W squared plus 24W plus 16 is what you'll get when you multiply it out. We're told it is 66 more than the area of a triangle. So, area of the rectangle, sorry. So we know that's going to be more, 66 more than the area of a rectangle. The area of the rectangle is W times 3W plus 4. So this times this. And so that's going to be, again, some straightforward calculation to do. I'm going to multiply that all out, take my time. So 3W squared, and then 4W plus 66. Now, bit of cross-fertilization here. So 9W squared take away 3W squared is 6W squared. 24W take away the 4W is 20W. And then 16 take away the 66 is minus 50. That's going to be equal to 0. So this is now a quadratic expression, which I can at least divide by 2. And then I'm going to factorize this. So again, 3 times minus 25 is minus 75. I'm looking for factors of minus 75 that can make 10 here. So 15 and minus 5 will work. And so you've got 3W squared plus 15W minus 5W and then minus 25 equals to 0. And then you can see these first two will factorize. So you've got that factorizing. So we have that, W plus 5, and then again you've got this, W plus 5. And so you're going to get two pairs, 3W plus 5, sorry, 3W minus 5, and then W plus 5. And the only one that's going to give you a positive answer is this one. It has to be positive because it's a width, and that's going to give you a positive width of 5 over 3, so 5/3, which means that the corresponding length was 3 times this plus 4, so that's going to give you 9 centimeters. So 5 over 3 and then 9 centimeters. Quite a lot of complex work for that, which is why it's 6 marks. Quite a lot of thinking. Okay, that's the end of the video for now. Thank you very much for tuning in. If you're first new to the channel, please do leave a like and subscribe. That would help me out a ton. And I will see you soon. I've got another video of these to do on handling data that will be coming soon. So do keep an eye on the channel for that in the next few days. Hope you're having a really great day and see you soon. Thanks. Bye-bye.